In this video, we're going to look at inverse trig function. So previously, we talked about Sohcahtoa. So I'm going to write it again because it's very important. Sohcahtoa. Sohcahtoa. Okay, very, very important. Okay, if you don't know what Sohcahtoa is, I'm putting up the card up above. So click on that and you can watch the Sohcahtoa video. Anyway, with the Sohcahtoa, we were able to find the length of a side, either hypotenuse, adjacent, or opposite, as long as we have one side length available and one angle, aside from the right angle, available to us. Okay. Again, you can look at the video, the Sohcahtoa video, for one example. In this video, we're talking inverse trig function. And what is it and how can we use this, right? If you know your inverse operation from your pre-algebra or algebra class, you know that multiplication and division, they're inverse operation. Plus and minus, they're inverse operation. Go more further, exponent and the radical, they're inverse, right? And we have more in the future that you will come across. But these are inverse operation. And in the similar way, the trig function and inverse trig function work. Okay? So for example, let's say we have sine of 30 degrees. Okay? Sine of 30 degrees. And what is that equal to? Sine of 30 degrees is equal to 1 over 2. This is a part of a special triangle, 30, 60, 90 triangle. But anyway, sine of 30 degrees is 1 over 2. With an inverse trig function, and this is how we write it, with a -1 sign, right? We can switch inverse sine of 1 over 2 is. And what do you think? You guessed it right, 30. Okay, so we can go the other direction. Okay, sine of 30 was equal to 1 over 2. So we can go other direction and take inverse sine of 1 over 2 to get to 30 degrees, right? And we can use this function to find the angles of our right triangle if we have enough side lengths available for us using the trig ratio. So let's take an example. Let's see an example. In Sohcahtoa video, we saw sine. So this time, let's look at a tangent. Okay, so we have A, B, C. Let's say this is 5 and this is 7.5. Okay, and we want to know this angle right here, angle B right here. Okay, we could actually find out how big this B is using 5 and 7.5. Okay, if this is the angle that we're looking at, this is opposite, right? And right next to it is adjacent and hypotenuse. Out of Sohcahtoa, we don't need to know h because we have no idea what our h is. I mean, although we could find that using Pythagorean theorem, but we have 5 and 7.5, so let's just use that. Which of our three functions has O and A? And there's only a single one, the toa, right? And that's tangent. So we use tangent. Tangent of angle B, we don't know that, is equal to 5, the opposite, over 7.5, right? Now we want to know what B is, so we could take inverse tangent, written like this, inverse tangent with -1 sign, of 5 over 7.5 is equal to B. So once we punch in that number, into our calculator, then we'll be able to find out how big the B is. So let's bring our calculator here again, okay? Turn it on. Make sure, though, your mode is in degree. Right now, that it's not in radian. Right now, it's in degree. That's good, okay? So I'm going to quit that. Okay, so we just need to punch in. Where is the inverse trig functions? You see the sine, cosine, and tangent? Up above, in blue writing, there's an inverse tangent, inverse cosine, inverse sine. It's kind of hard to see, but it's right there. To access this blue button, you press the second, okay, and then press the button, and that gives us inverse tangent. Now we get inverse tangent, and then we have to put 5 divided by 7.5, right? And then press enter. And that gives us approximately 33.7, right? Or we just round more, and then we just say 34. So we'll just say 34 degrees, okay? So using the inverse tangent, we found out that angle B is approximately equal to 34 degrees. And once we know that, if this is 34 and that's 90 degrees, then we can easily find out what A is, right? Because angle A and B are complementary, so 90 minus 34 is going to be equal to angle A, right? So we can easily find that, okay? So that is inverse trig function. And depending on the situation, you could decide whether you're going to use a sine, cosine, or tangent, Sohcahtoa. Just identify what is the angle in question, what measurement do you have available to you, so then you can decide whether to use a sine, cosine, or tangent for your problem, okay? If any other question, please leave a comment, and see you next time. Good luck.